Okay, afternoon everyone. My name is Laurence and I'm from Revolution Analytics. Just a show of hands so I understand the audience a little bit. How many of you all are using some form of analytics already in your games design and so on? What sort of, for those that raise, maybe what sort of tools are you using? Are you write your own, or are you using R, or using SPSS, or?
We design or refine our own tools because the format of the assessment that you're using, it will require a customized tool, and you couldn't find anything industrial you can actually match it directly.
Okay, okay. Have you heard of R?
No, we haven't tried that.
Okay. Okay, good. Revolution Analytics, just a quick background. It's a US company that's been around for 5 years. We provide a commercial version of the open source R statistical programming language. Now, it is now it's more or less now the de facto standard for statistics in undergrad and graduate level. Most of the maths and stats students that you meet today, the fresh graduates, the last 1-2 years, would have done one or more courses with R, or have done a full-fledged project with R. Okay, so that is now the standard skill sets that all these people graduate with. And it came out from academia, but today is used widely in industries. Our biggest customers are in life science, telco, the intelligence community, and so on. And of course, finance. What I'd like to share about today really is the use of analytics, how it's being used, and big data. And I think in the industries that you are in, as your customer base grow, you will definitely come up to the big data challenge. And what is this whole thing about big data all about, right? And what are some of the industry best practices in solving this? Facebook, not a serious game, I guess, but they are, nevertheless, they have a whole community of 1 billion people. They just announced earlier today. They use a lot of analytics for various things, recommending the friends and so on. That is done by very sophisticated models at the back end. But beyond that, they're also using it internally. And this is actually a very interesting use of analytics. Matching peers who are, if you are a Facebook employee, so this is Facebook HR, right? If you are a Facebook employee, you naturally have a Facebook account, and they actually see how you interact among your peers, and from there, they can actually do peer review and try to build dynamic teams. And all of us are in the software industry, you know, the software that you create, it is the brain power. It is the team that you're able to put together. That is the one that will help you, create the best tools out there, right? And Facebook, to succeed, needs to make sure that the team that they form to work on projects can work well together. So they use actually a lot of machine learning models to do that. So with this is the same idea that some of our customers are experimenting in the learning management systems. How do students interact with each other as they form their own little team, they answer the questions, do the group studies together, and so on. Okay, so we actually have 2 or 3 partners or customers in this region that's looking at that. So Facebook use R extensively, and they do like peer reviews and performance reviews and so on, right? And how to set up optimally constructed teams. And giving managers insights into employees' interactions. So that can be applied to, let's say, a student or your game environment. How do the people interact and interact with each other? This is not so much more games, but more an overview of how the industry are using analytics and in a big way. I'm sure most of us have an Amazon account. Orbitz is an online travel agency. Similar, you can think of Amazon. Every time you go to Amazon, Amazon welcomes you back. They know, even you don't buy anything from them, your surfing patterns is very useful information to them. They know what you're looking for and so on. So all these are being tracked, analyzed, and you get all the dynamic content pushed to you, right? They will know when your buying behavior change. When, just like for me, I recently became very interested in photography. So all of a sudden, I started looking at a lot of photography books. So now when I go back, Amazon or sends me an email, right? Oh, there's a new book, do you want to buy, and so on. So they can pick this up after one or two visits. So Orbits basically use R, traditionally mining their transactional data, that means completed actions. But today that is not that interesting anymore, because that's well known. What are people doing today that is really very exciting is non-transactional data. That means data that was not completed. That means someone didn't use a credit card to complete the transaction, but surfing patterns. So very much like, let's say, in the gaming industry, right? How people are interacting with your games and so on. Those patterns can generate a lot of insights into how people are using your system. I met a big game developer a couple of months ago, and he told me that they use a lot of analytics because they spend, let's say they spend $1 million or $2 million to create a new landscape. They want to make sure that that is being used. And they collect a lot of analytics during the beta period, because if no one is going up that hill, for example, they want to know why. Is there something, a tree or a boulder is blocking the path or something? They want to know, right? They spend $1 million building that. So they collect a lot of analytics to understand that kind of behavior. There's a lot more in marketing, and and this is really big data. So this customer upstream is processing about 5 billion scores per day per customer. And of course, they don't just have one, right? They have several customers. And all the data is coming in real time from various marketing channels, collecting various behavioral statistics and so on. And they have their own proprietary data. So they collect all this data on behalf of their customers. And all this is stored into Hadoop. That is a big data platform. And how many of you all have heard of Hadoop? Okay, good. So Hadoop is being used to store all this unstructured data. And then they set up a big cluster that runs our software to do the analytics. They pull the data out of Hadoop, process it, and then pump it back into Hadoop's HBase for structured data. So just a word of caution, I've been speaking at a lot of events, big data events, and Hadoop events, and everybody thinks, or a lot of people think, that Hadoop is the one and only thing that they need, but that's not true. Hadoop is good for certain things, but it doesn't solve all your problems. You always need to complement with other technology. Okay. So what is big data, and why should you guys be concerned about it, or understand what is it, and where are the opportunities, right? This study basically estimated that there will be about 200 billion savings in U.S. healthcare spending as more and more of these healthcare players adopt advanced analytics, and because of big data, they're able to store and process all these and get a lot more intelligence, right? Like what drugs is good, what drugs is working, what drugs is not working, and so on and so forth. And 50% decrease in product development costs. I think this applies to a lot of, I guess, you guys here when you develop your games, right? By collecting a lot of data and doing analytics or analysis on it, you'll be able to either streamline your process or make it a lot more efficient. So what exactly is big data? Not necessarily it's the size of that data. Okay, size doesn't always matter. So in big data, volume, yes, terabytes are very typical. But besides volume, there's actually two other components that's important. One is velocity. So Twitter, as all of us know, the data of Twitter is very small, 140 characters, 40 characters. But if you were to start mining that, it becomes big because of the volume, right? The velocity, the speed at which people are tweeting. And if you start mining that, it becomes huge. And the other part about big data is about variety. 10, 15 years ago, people were not looking at unstructured text and so on, because the technology was immature and was very expensive to try to do text mining and so on. But today, people want to understand what people are talking about their brands on Twitter, on Facebook, and so on. So unstructured, semi-structured data is a component, all right, of big data. So when people talk about big data, it's three things, right? It's the size, the volume, the velocity, and variety. Okay, so it's just not say if you have 10 terabyte data and it's static, it's not big data, right? The next 1 year, hard disk size, CPU cost will have come down so much that you can process that 10 terabyte easily. But if you're growing at 5 terabyte every month, oh yeah, then that's big data. So why this interest in big data, right? So it's really about better predictions. For those of us who did engineering or maths, you would probably have taken a statistics course, right? And your professor will tell you, oh, you need to do sample. You study about sampling and so on. And the reason is, it's not that the mathematics wasn't there for you to analyze all your data sets. It was just simple economics. It was just cost. It was just not cost effective for you to process all the data that you could get your hands on. It was just too expensive. Imagine if the technology like Hadoop or even like R was not around, and today you need to process hundreds of terabytes of data. Just not easily achievable, right? It will be too expensive, right? I mean, not everyone can have the money to buy a Teradata or a EMC Greenplum and store 100 terabytes. But today, to store 100 terabytes, I can do it very cheaply. I just go across the road to Funan, Sim Lim. I buy 10 servers, load it up with 1 terabyte hard drives. I can store 100 terabytes, right? Powerful models. People are now building very, very powerful models to process big data. Our companies are working with some of the leading companies. In fact, I just saw them on the news yesterday. And building beyond, right, linear models. In real life, right, nothing is linear. So they are non-linear, and in analytics, there's something called mixed models. So our companies, rather my company is building mixed models for some of the very big organizations in the world. The other thing about big data is rare events, or what the community calls black swan. A very good example of this is insurance claims. Most of us would have some form of insurance, but when you make a claim, that's a rare event, and it's very hard for the insurance companies to model that, right? So today, with big data, they could actually capture all the data, right, and process that, so on. So this is really the reasons why we are able to do big data. Storage cost has dropped over the last 2 decades. 3 decades, right? A terabyte was 14 million in 1980. Today it is $300. It's probably cheaper now, right? You just go to Funan or Sim Lim. A CPU, I'm sure all of you have an iPhone or a Samsung phone. That CPU in your pocket is probably more powerful than the first Cray supercomputer when it first came out, right? I remember when I started work with Singtel many years ago, right? We were on 10 megabits per second. Today, most corporate network is gigabit, right? So it's really about economics, right? So CPU's processing speed, data storage speed, the costs have come down so much that you can now store all your data and process it, okay? So what are the technologies that you need to look at as you think about putting this whole analytics stack, big data stack, as part of your solution offering? At the lowest level is how you need to store the data. How are you going to store it? In open source, of course, you have the traditional databases like MySQL, Postgres. Those are traditional relational database, you have your NoSQL type database. Those are great. And then, of course, you have Hadoop, right? The king at the moment. So use Hadoop wisely, understand what is good at, what's not good at. And I always advise my customers, if you are thinking of building Hadoop, if you are not budgeting for at least 50 nodes, you probably don't need Hadoop. Okay? A lot of people say, I'm going to do a 10-node Hadoop cluster. I say, yeah, that's good for POC, not to test performance, to test whether your code works well on Hadoop, right? Whether it even works, whether your algorithm works in Hadoop. Because you don't see any performance benefit unless you scale to what I call Hadoop scale. That means if it's not beyond 50 or 100 or 1,000 nodes, 10, 20, 30 nodes, I bet you I can do the analytics faster on a single server with lots of RAM. Okay? So be careful about Hadoop and its purpose. Further up the stack is the analytics stack. Traditional players are people like MATLAB, Mathematica, SPSS, SAS, and so on. Scientific Python, for those who likes Python, and R. Now, if you have not looked at R, I would highly advise you guys to take a look at it. It's been around for the last 18 years, very matured. It is a programming language. Whatever you were saying that you couldn't find something that you could have probably built your solution with R in 1/4 of the time. Because most of the analytics that you will ever need or you hope to use is available in R. One of the big organizations that I spoke to here said they use R. Why? Because the latest, greatest algorithm by some of the world-leading statisticians and maths guys are published in R first. The moment it's published, they can download the code, the paper, and test out the algorithms. Okay, so I think if you have not seen R, take a look. It is a programming language. It's not a GUI tool where you click, 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 and you generate some beautiful charts and results. No. You need to get your hands dirty. You need to program. Okay? But with that, it comes a lot of power. So I had a email from an audience when I gave a talk a couple of weeks back at the university. And he said that, no, he used the traditional SAS and SPSS. But all he learned was how to push buttons. But when he discovered R, he found out that the process of getting the results gave him a lot more insights into understanding his data. And ever since he's been advocate, he's been trying to convert all his other classmates to use R, right? So R has that habit of making people very passionate about data. If you are just seeing dialog box and pushing buttons, you're not going to be passionate about your data. Now, for those of us who, I'm sure you all here are building games and so on, but and some of these games could become analytics services, right? And that's where I see the next big area where if you're not building a product and you're thinking of offering services, then you could specialize in a specific domain that's very sorely lacking in the industry at the moment. The problem is the last 10, 15 years, a lot of people were just pushing dialog boxes and buttons. People didn't really understand the data, right? Everything was a black box. But in today's day and age, people need to understand data, and organizations is not scaling up fast enough, and now are looking for external consultants, organizations to come in and supplement their BI team or analytics team. So there's actually quite a fair bit of money to be made in that space. So R, I've mentioned already, it's software. It's a programming language. It's a whole environment where you will program. You can do your data manipulation and so on. It's open source. You can download it. There is 4,600 packages today for R, ranging from life science to finance to econometrics to whatever you can think of. There's probably a package already written. And because it's a language meant to do data analysis, it comes with very powerful sets of visualization and graphing capabilities, right? If you you open up any statistics paper, most of the charts there are drawn in R. But for us laymen, go to New York Times. Most of the graphics there are drawn in R. New York Times has one of the biggest and most sophisticated data science team in the world. And this is just a newspaper publisher, right? But why do they have that? Because they want to present data in a very easy to understand, very easy to consume manner to their readers, right? So they are using R a lot to analyze data that they collect and publish. So why R, right? I mean, when I talk about R, it can be open source R, right? It doesn't need you don't need to buy Revolution R, the commercial version for me. So, but this is really generic R. It's about talent, right? Today, if you are building up a team or you have a startup building games, you hire fresh graduates. They come with R skills, ready to go. If you look at over the last few years, R is the one that is the papers on statistics and so on are being published in R. This was a comment from Forbes about the US a couple of years back, but this exact comment is the same over even in Singapore. I was very surprised when I first started with Revolution. I thought, they're probably not, universities probably not generating that much, but after a few weeks, a few months, I found no. Our universities are all using R and all the students are learning R. It's about modeling innovation, right? You say that you look around and you couldn't find, because you were probably looking at packages, SPSS or SAS or something like that, right? Some of those packages that give you pre-built, and this is what the set of algorithms I have, and that's all you can use, or these are the APIs that you can call. But because R is a programming environment, it's a programming language, you're only limited by your creativity. Okay, so lots of different areas that you can use. But of particular interest, of course, is things like social networks and data visualization. So there's actually a lot of work that we are doing for a lot of customers in social networks and data visualization. Okay, and data science. Now, as you guys go out and build, you probably have the IT knowledge because you are building games. You probably have the domain expertise if you are building serious games or learning games and so on, management games. You have the expertise, but to make your games a lot more, I won't say smarter, but so that you collect enough statistics to make it a lot more powerful for next versions and version after that, you need to supplement that with analytics, right? So you have your IT skills, you have your substantial expertise, your domain, you need your maths and stats knowledge. So these are the three pillars that together is what people are now calling data science or data scientists. Now it's very hard to find a data scientist. It's very rare to find someone that have all three skill sets in one person. So typically this is a team, and usually I see a team of two. Okay, because most of the time the IT person will have gained sufficient knowledge over time working with customers to gain the domain expertise, and then he can supplement that with someone that has a little bit of maths or stats background, so that when the models you build make sense. Okay. And data exploration and visualization, again, this is all about understanding your data. So this is a very interesting chart that Facebook did with R, and they basically join up, because in Facebook you sign up, you basically tell them where you stay, right? So they say, okay, I'm your friend, so I just draw a line from me to you. That's what this guy at Facebook did. It so happened that after drawing those, at that time probably not 1 billion, right, but probably 600 million or so people, it ended up looking like this. And this is not an atlas. This is a line connecting friends. It ended up looking like an atlas. It's a very interesting chart, right? So it gives Facebook all of a sudden an idea, whoa, I'm all over the world. It looks like an atlas, but it's actually not an atlas. But you see that, over on the top right, it's actually black, right? Yeah. China, right? There's no Facebook in China. So when this chart came out, a lot of people then realized the power of R and graphics. And a lot of subsequent charts use the same techniques. So a lot of charts you see, very interesting graphics you see online today, are all using the same idea, right? Drawing GIS applications, joining lines, and very, very interesting graphics. So lots of very advanced, and this is actually a decision tree, right? Again, in typical statistics, you probably will be only able to handle a few trees or rules, and that's it, right? Because you won't be working with that huge data sets. But today, with Hadoop and R and clusters, you can actually process all your data. So to do all this big data analytics, you need speed and performance. And I have to admit, this is a sales slide to say why you should buy Revolution. But I'm also a firm believer in using the right software. Right? It's always better to pay a little bit for commercial software to get the extra performance. My background is in high-performance computing. I've been selling clusters for the last 15 years to various organizations all over the world. And I always advocate, please, open source is great. GCC compilers are great if you're just compiling on your workstations and testing your code. But if you're deploying on a cluster, please be mindful of your colleagues. If you recompile with an Intel compiler or a commercial compiler like Portland and you get 10-20% speed up, it means you can get out of that cluster at a faster time and allow your other friends to use the shared resource. Or it means if you're buying a cluster, instead of buying 100 nodes, you could buy maybe 80 nodes and solve the same problem in the same amount of time. And with that savings of 20 nodes, which could translate to like 200,000, you can do a lot of things with that money. And how much does it cost to buy an Intel compiler for an academic? $1,000. Think about it. With $1,000, you save 200,000 just by getting more efficient code. And that's what we're talking about here. So we recompile open source R with the Intel compiler in this instance. We use several Intel tools. And you'll see that beyond that, of course, we have our big data algorithms that we optimize for multi-core and so on. You could go from a something like 600 seconds down to 80 seconds. Right? That's nearly a 10-fold speed performance improvement. That is the difference between a 10-node cluster, if you are doing analytics, and a 1-node server that you need. Okay? So one server is, let's say, typically in the range of about 10,000. You are saving $90,000. Our software for one server license is 20,000. You do the maths, right? It makes sense. I was very sad that a government agency that I spoke to I approached them too late. They spent $1 million to buy 2 servers, each with 1 terabyte of RAM. They were processing this sort of huge data, and they were using R. And one of the problems with open source R was that you need to load everything into memory before you can do the processing. And they spent $1 million just to do that. And I said, well, you could have saved, no, did they spend? They spent, yeah, $1 million. No, 500,000, sorry, not $1 million, 500,000. I said, you could have saved 400,000 if you were using our software. You could just use it on a normal 32 gig RAM server and solve the same amount of problem, solve the same size of problem, right? So, and when I gave a talk yesterday, the day before at Taipei, I was in Taipei at the National Supercomputing Center. Same thing. They were laughing away when I gave this example, right? And they said, oh yeah, Lawrence, we did spend that much to buy this server with 1 terabyte of RAM because we were using R and we need to load everything into memory, right? So use the right software, it will save you a lot of money. So as I engage my customers, this is more or less the standard enterprise architecture that we are seeing in organizations today. They have a mix. They use a lot of Hadoop, right, to store those data to basically for pre-processing. And after that's stored, typically they will translate to a more permanent data store, a data warehouse, like NetTeaser or Teradata. And the data scientists themselves will typically be working off a smaller subset of it in their own servers or clusters. And the reason is not about technology, it's more about operations. IT will not allow you to run a big unknown analytics workload on their data warehouse, which may screw up all the production schedules. So it's just being practical. So this is actually quite a typical environment that I personally have encountered a number of times already. So how do you start with analytics? Just use your laptop, right? You'll be surprised, right? Today, this laptop, unfortunately, it's only an iCore 5. But you can load it up with some RAM, 4, 8, doesn't matter. You can actually process 1 billion records in several minutes. That's how powerful modern day computers are. And with the right software, you can do that, right? So, for example, this example is if you download R, this is a pretty well-known data set whether it's a boy and the mother and so on and so forth. So it's some form of birth records. It was done on a laptop in 6 minutes. Okay, and this is how R code looks like, right? It's actually programming. And if you need to make it go faster, that same piece, right, can run on a cluster, right? A cluster means several servers, 8, 16, connected with a simple gigabit network, run. And you can run it in parallel. And we did this in 42 seconds. No need for you to program in parallel or MPI or any of those fancy stuff. With the right software, that's done for you automatically. So you can start with a laptop or a small server. And if that is not enough, you scale up to a cluster. Okay? If a cluster is not fast enough, which is very unlikely, if you need to really go to Hadoop, then you are then your business must be really, really very good. Okay, so when we talk about big data, there's not 1 billion records today. You can do it on a laptop. It's no big deal. When I spoke to one of the analytics company a couple of years ago, I said, oh, you need, I was selling hit clusters, right? Oh, you need to use a cluster to solve all this. Laurence, but Singapore, 4 million. With 4 million people, how much data is there? And one server, we can do all the analysis, right? So that was about 4 or 5 years ago. People haven't talked about big data yet. So what's the outlook for big data and analytics? Cloud. If you're writing your software, do think of hosting it on the cloud rather than running it internally, because ultimately, to get value out, typically you need to interact or pull data from other data sources, be it Twitter, social media, and so on. And a lot of those are already on the cloud. So if you are sitting on the same cloud as them, it makes it a lot faster. Expect lots more data. Demand for data scientists. So unfortunately, if you're a small game startup and you're trying to look for data scientists, it's going to be very hard to find and very expensive. So because the demand for them is just huge, right? Organizations, even here in Singapore, are hiring PhDs to build their data science teams today. So I do advise my customers, look, some of these are SMEs, right? You are not going to compete with the Singtel of the world, right? Just go and get the fresh grads from NUS and NTU, right? They can be a good start to form your data science team. So think of new data platforms, right? I mean, think of clusters, think of Hadoop as you are building up your platform to collect data and do this sort of analytics. The traditional, big Teradata or SAS, those just can't catch up. SAS, by the way, is a 40-year-old legacy software that has not changed. Okay, and one of our ex-CEO was formerly the founder and inventor of SPSS that came out at the same time as SAS. And they know each other very well. They know the limitations. They've been fighting to each other for 40 years, right? And he became the CEO of Revolution. The reason is that he wanted to change SPSS, but the board didn't agree with him. So they sold it off to IBM for 1.2 billion. So IBM has a 1.2 billion legacy software. Good luck to them. analytics of big data analytics, right? The cloud. So I believe you have heard a lot about the cloud, scale on demand, pay as you use. So that's great. That's all nice, and it's all true, right? I've been involved in cloud for many years. But the key thing is about data that sits there, right? And if your platform is already there, it just makes accessing those data a lot easier, right? And there are lots of data, and as the Singapore government start to realize that, hey, there's actually a lot more value if they open up their data to other people to access, like what the US and UK is doing, they could generate a whole new industry, right, just from data alone, rather than just keeping everything to themselves. And expect R to run on the cloud. Not just R, other analytics software, right? It will start to run on the cloud, and you have more of that. And that's where I talk about, having the experts. The experts will be there, I believe, that will help companies who don't have the expertise to use analytics. Just like, it may be very expensive for you to hire or get a particular expert in the domain that you want full-time. But with cloud and tools that we are building, these experts could actually be rented per hour. And that's actually a very interesting work concept that is actually getting very popular now. Okay, so there are several companies that actually do nothing but do this sort of ran by hour experts, right, that you could get, right? So, and the good news is that this platform that I'm talking about will be here soon, and we are building this right here in Singapore. So my team is actually building this. Beta will be in first week of December. That's planned. So if any of you are thinking of doing some form of analytics, and you want to do analytics on demand, then this platform is here for you to try. Yeah, it's going to run on AWS. We will open up we probably can't accept everyone as beta customers. We are looking at about 20 or 30. We already have about 7 or 8 people sign up just in this region alone. Because I only started talking about this 2 weeks back. So the good news is this is done here. The team is here. If there are any specific API enhancement or changes required to change to suit your requirements, it's easier when you can just buy me a coffee and we can talk over coffee, right? So yeah, that's all I have.